Hey guys, welcome to another chemistry video, and today we're going to learn about how to name hydrocarbons. So if you don't know what hydrocarbons are, I strongly suggest you to watch the previous video because we talk about the properties of hydrocarbons and their structures, which are going to be and that knowledge is going to be very useful in this video. So please pause right now and go watch that video if you haven't done so. So naming hydrocarbons. To name a hydrocarbon, we're first going to need a hydrocarbon. So let's find let's talk about the hydrocarbon of pentane. So let's I'm going to, instead of saying the name, I'm going to name the chemical formula. So we have C7H16, which is 7 carbons in a row. I'm just going to draw the straight chain for now, and then I'll get into branch chains and how to draw them later, or how to name them later. So I threw the 7 carbons in a straight chain, and the hydrogens are sprouting out from each of these carbons. So since there's 7 carbons, this molecule would be called heptane because it has 7 carbons, and hept is the prefix with 7 carbons. And if you don't know that, or don't know the prefixes of any other hydrocarbons, you should watch the previous video because we explain it there. But since most times, well, in all hydrocarbons uh with 7 carbons, there's always going to be the heptane root in it, no matter what. So you're always going to find the word heptane in it, even if it's like the suffix of something. There's always going to be the word heptane in it. So now let's draw. Now that we have that, let's talk about naming branch structures. So let's start off simple and go with this. So as you can see, this is a branch shape, but we have a continuous stream of carbons. And when I mean continuous, I don't have to lift my, I can draw one, I can basically draw a line through it. It's not a straight line, of course, but I can draw 2 lines like that. So it's continuous. So basically, you can draw a structure, you can name a structure like this if it's continuous. I can name a structure like this and call it, so in this case there's four carbons, so this would be known as butane. But even though it is branched, it's still called butane because we have a continuous stream of carbons. But if we have a shape like this, and there's 1, 2, 3, 4, 5, 1, 2, 3, this would not be called heptane. I mean, this would not be called octane because even though there are 8 carbons, this is not a continuous stream. I have to relay backwards down this line to get back to the other pair. So we'll talk about that later, but just know that that's not a continuous stream, and instead it would be called pentane with some additional words, obviously. And now we have this butane right here. So now let's talk about a scenario where we would have a branch chain, but it's not going to have the regular name that we know. So let's think of one molecule that has no double or triple bonds, because just for simplicity, we'll get into that later. We'll get into alkenes and alkynes and how to name them later, but first let's get down the alkane part. So let's choose, say we have pentane. Now let me pull up a diagram of pentane. So we have our picture. Uh-oh. So we have pentane, but notice how even though we had a branch chain at one of the ending carbons, it still was butane because it was a continuous stream. So in order for it to not have a continuous stream, we would have to start in one of these middle carbons instead of the edge carbons. So basically, these carbon adding a substituent group to these carbons would not work. Therefore, we have to choose one in the middle. So now let's draw this. So several questions may have been raised up in this when I drew this diagram. And one could be, well, you said that the name of the molecule depends, the hydrocarbon depends on how many carbons there are. And this is not, this still has the word pentane in it, but it's not a structural isomer of pentane. So we'll talk about isomerism later, but in the next video. But this will still have the word pentane in it because the parent chain, or the longest chain, is still a strand of 5 continuous carbons. And fun fact, a stream of continuous carbons of the same type, or continuous atoms of the same type, is called a homologous series. So a hydrocarbon is a homologous series because it's a repeating structure of carbons. Anyways, to name this hydrocarbon, first we must determine the parent chain. So to determine the parent chain, we need to find the longest strand of carbons. So as we discussed before, we have two options. We have the straight one. We actually have three options. So we have 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, which is the straight chain. Or we have this 1, 2, and then 3. And we can't go back down because that would not be a continuous structure. So we have 3 carbons. And if we start from the other side, keep in mind that you can start from the other side if you want to. So if we start from the other side, we have 1, 2, 3, 4, 5. So we have 5. Since we have to choose the longest one, we have a 5 and 5. But most times, for convenience, we will always go for the straightest one, and in this case, it is this straight chain. So we determined that it's gonna have pentane in it, and now obviously it can't just be called pentane, or else, because this molecule is different from this molecule, therefore we need to find a difference, and the difference is this substituent, or the functional group methyl. So a methyl group is basically CH3, and I believe we covered this in the previous video, but substituents are functional groups, and functional groups usually have 1 hydrogen less than its molecule. So methyl is very similar to the name of methane, and methane is a formula CH4, and since functional groups have 1 less hydrogen, then it's like I'll just call it parent molecule. Since it has one less hydrogen in its parent molecule, it's gonna have the formula CH3. So in this case, CH3 is substituting this hydrogen, this original hydrogen, if it was just pentane, and it's substituting it at this second carbon. So we got two pieces of information here. We got that it's substituting at the second carbon and that it is a methyl group. Therefore, the name would be 2-methyl pentane. So let's recap. It's called it has a 2 in it because it's at the second carbon, and it has a methyl group, and for that reason it has the word methyl, and then we have pentane at the end. So let's also come up with the other name if we use this strand. And you also might be thinking, let me just address this before any confusion erupts. So if we started from this way, we started from the right. This is also legal. You could go from 1, 2, 3, 4, 5. But oftentimes, well, all the time, we refer to the least, to the carbon that has the least value. So when I say that, I mean, as you can see, this substituent group is connected to the second carbon. But if we started from here, it would be connected to the fourth carbon. And we always want to deal with smaller numbers. So we start from the side that has the substituent group first. And that's why we started from the left, then the right. Now let's do the shape that would be this, where we had 4 carbons. We had this carbon, this carbon, this carbon, this carbon, and this carbon. So it's still a pentane because we count 5 continuous carbons. So it's going to have pentane in it. And if we start from this, if we use this, we can still see that there's a methyl group at the end of this carbon. And this carbon is the fourth carbon or the second carbon. So it's the second carbon if we start from this end, or the fourth carbon if we start from this end. And as I mentioned before, we always wanted to do the smaller number, so it's the second carbon. And as you can see, the name still stays the same. No matter, it's still the same structure, therefore it makes sense for it to have the same name. So now we have 2-methylpentene. Now let's talk about another scenario. Now let's talk about alkenes and alkynes. So as we talked before, alkenes have double bonds and alkynes have triple bonds. So when we draw this out, let's draw ethene. So we have H, C. Actually, let me get a better example. I'm actually not going to name this yet, so we can actually name in the activity. But let's say we have forgive me, I just want to make this diagram as accurate as possible. So you might be wondering why it's going to have the bench shape, and that's because we have this double bond. And since we have this double bond, it's going to be forming the trigonal shape. And if you don't know what that is, you can trigonal planar shape. If you don't know what that is, you can watch our molecular geometry video. But that's it, and we should have. So let's name this molecule. This is the standard straight chain because we have a continuous stream of carbons. So we have 1, 2, 3, 4, 5. So it's going to be another pentane, or it has 5 carbons, so it's going to have the prefix of pent. But since it has a double bond, it's going to have the suffix of ene, so it's going to be called pentene. Since it's called pentene, we know that's going to have the double bond, and keep in mind that the double bond can occur anywhere throughout the molecule. But since we want to be specific, in order to find the location of the double bond, we're going to count the carbons until where it occurs. So if we start from over here, it's going to start from 1, 2, 3. So the double bond is between the third and fourth carbon. But since we're just counting where it starts, it's going to be the third carbon because it starts with the third carbon. But this, as we said before, we want to have the least number. So if we start from this end, we're going to have the first carbon and we're going to have the second carbon. And now over here, it starts off with the second carbon again. So this is going to be called 2-pentene. Now don't be confused between these two examples. This example is for the functional groups, whereas this scenario is about locating the double bond in the alkenes and alkynes. And you might be wondering how we can incorporate both if a molecule does require to do so. So in order to do that, let's come up with another molecule. So just gonna erase this so we can have a clear space. And this is gonna be a big molecule, so it has all of the instances of what I want to include, because there are many instances of hydrocarbons, and I want you guys to know most, if not all, by this video. So there we go. Let me just clear the space out a bit more. Okay, so first thing we always do is count the amount of carbons in a continuous chain. So there's two possibilities, or there's actually many, but we have this continuous chain where you can see right here 1, 2, 3, 4, 5, 6, 7, 8, 9, or we have 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, or we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I also had to do the 10 over here. My bad about that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So obviously we're going to go for this longest chain. And that is going to be, let's just start off from here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just as convenience. So we know it's going to be a decane because decene because it has a double bond and it has 10 carbons. So it's going to be a decene. And now I like to I just like to separate the substituents from this the parent chain in order to get a clear understanding of what we have to add on. So we have to add on this one, this, and this. So we have to add on this ethyl group, which has C2H3. Again, the chemical formula for ethane is C2H4, and since it's a functional group, it's going to lose one hydrogen, so it's going to be C2H3. And then we have three methyl groups actually, one over here, one over here, and one over here. And now we're going to be finding some other methods to write the names. So just like we try to choose the smallest number of something, we also like to go in alphabetical order. So when adding the groups on to the name of the molecule, we always want to go with the name that has that comes first in alphabetical order. So we have 3 methyl groups and 1 ethyl group, and E comes before M. So we're going to start off with the ethyl group. So the ethyl group is at the second carbon, so we're going to have 2 ethyl. And that's pretty simple. So now we just need to go on to the methyl groups. So we have 3 methyl groups, and we're not going to just do 3 we're not going to like do 1, 2, 3, 4, 5, 6. We're not going to do like 7 methyl and then 8 methyl and then well, there's actually 2 8 methyls, but essentially we actually it's an abbreviation. So we do a dash, then we do 7 because that's where the first methyl group is. Then we do 8 because that's where the second methyl group is. And we also do another 8 because we have a second methyl group attached to this 8th carbon. And that's why you have 2 8s. And this is perfectly fine. And it's accepted. You'll see this a lot in problems if you take chemistry in school. So now I'm drawing trimethyl. Let me just get this clear. You might be wondering why I'm saying trimethyl. And as we discussed before, hydrocarbons like to use abbreviations, suffixes. Just try to do the simplest way that describes the most information as possible. And that's why we have the tri. The tri signifies how many methyl groups there are in the hydrocarbon. Just to reiterate, even though we have these numbers, it's better to just use trimethyl because it's mandatory and it's the proper way of writing it. So we have 2 ethyl 7 8 8 trimethyl decene. So this is the proper way of writing it, and I will end the video here. So if you guys have any questions, please comment below, and next video will be more we're going to be talking about isomerism. And if you guys feel like we need another video on this, because I know this is a large topic, but if you need another video about this, just comment below and subscribe for more content. Thank you.